Okay. So now we're going to do another system of linear equations problem. This one has to do with a cooler that has two kinds of bottled water, and it goes like this. A cooler has two brands of bottled water. It has 35 bottles. If one brand costs $1.25 and the other one $35, and the value of the bottles in the cooler is $44.95, how many bottles of each brand are there in the cooler? Okay. So again, I think by now you can probably start to see the pattern that these problems have, where you need to have two kind of constraints on these two. You have to have these two constraints that give you the ability to get both of the values. Yeah. In this case, how many bottles of brand X and how many bottles of brand Y. So let me first state what our variables are going to be. So I'm going to let C stand for the number of $1.25 bottles. Bottles. And I'm going to let E be my number of $1.35 bottles. Okay. Given this setup, we're now prepared to make the system. By now, I think it's clear that C plus E has to equal 35 because there's 35 bottles, and that 1.25 times C plus 1.35 times E will give us the 44.95. And so now we have set up our system of equations. And now, just as before, we're going to begin to perform the elimination method. Step 1, we're going to solve for one of the variables in terms of the others. One moment. Okay. So in this case, step 1, we're going to, let's say we take the first equation, subtract E from both sides, and we get C equals 35 minus E. Okay? So in other words, I just took the first equation and I subtracted E to the other side. Gives us this. So that is our step 1. Done. Okay. I'm now going to insert this into the second equation to eliminate C from the second equation. So that's going to be step 2, which is the elimination step. So it's going to be 1.25 times 35 minus E plus 1.35 E equals 44.95. Okay. Now we're getting somewhere. Okay, now. So now we have to distribute like this. So here, 1.25 times 35. Let's do that here. 1.25 times 35. 5 times 5 is 25, so we bring down the 5 and we carry the 2. 5 times 2 is 10, plus 2 is 12, so we bring down the 2 and we carry the 1. 5 times 1 is 5, add 1, it's 6. Then, we're going to multiply the 3. 3 times 5 is 15. We carry the 1. 3 times 2 is 6. We add 1, it's 7. And 3 times 1 is 3. And so we can see that we get 5, 7, 13, carry the 1, 4. And here, because there's 2 decimal places, there's 2 decimal places here. So we now know that this is 43.75 minus 1.25 E plus 1.35 E equals 44.95. Okay. So there we go. We see that we have an equation only in terms of E now, and we're working on solving that one. Okay, so now what we want to do is we want to get this 43.75 to the other side. So we're going to subtract it. Minus 43.75 minus 43.75. And additionally, I want to point out to you that we have these like terms on the left-hand side of the equation. And so if we have negative 1.25e plus 1.35e, that gives us a positive 0.1e equals, and now we can perform the subtraction. 5 minus 5 is 0. Right? This 5 take away from 5 is 0. 7 minus 9 is 2. Then we do our point. 4 minus 3 is 1. And so we get left with 0.1e equals to 12. The 4 minus 4 goes to 0, so that's it. So therefore, we divide by 0.1. We divide by 0.1. And we get that therefore E is equal to 12. Okay? Now you could do that in one of two ways. You could do that with a calculator, 1.2 divided by 0.1. You could do that looking at it in terms of multiplying the top and bottom by 10, in which case you'll get 12 divided by 1, and then that's obviously 12. You could also convert both of them to fractions and treat them as fractions. But so here, you know, but here the most important part is knowing how to do this setup and do this procedure of elimination. Yeah. So now we've gotten our E, which we saw was the number of $1.35 bottles. And now finally we can figure out what our C is, our number of cheap bottles. That's why I called it C, cheap bottles. And so our C will equal to 35 minus 12, which is going to be 5 minus 2 is 3, 3 minus 1 is 2, so it'll be 23 of the $1.25 bottles. And there we have it. We have just solved this cooler problem. Yeah, super cool. Ta-da!